Hey, what's up with you two? We are doing great. Good job, ladies. Good job. We are here with some of the most amazing robots you've ever seen. And guess what? They have been created by high school students. When we come back, it's a big competition, and it's sponsored by NASA. Maybe some of the future NASA engineers are in this room. Kicking it with Kenny. Stay with us.
He's kicking it so hard this morning. Hey, Kenny, good morning.
Yeah, I might sprain my ankle. That's how hard I'm kicking it.
No, we need you
All
tonight.
right, don't worry. Yes, I'll be there. Yeah.
Did Capo tell you she's not going to be there? She's not going to show? Did she mention that to you?
No, she's better show. She better show. She's our spiker. All right, it is the Super Bowl of robotics, the NASA robotic competition. We have some of the most brightest high school minds in the city. You like that? Man, it's pretty good, huh? All right. All right, we have the meteors from Midpark. Good morning, gentlemen. Good morning.
Good morning.
How you guys doing? Introduce the members of your team there for us.
We've got Mike over here. We got Sean. I'm Garrett, and this is Kyle.
Okay.
And this is Kyle.
And that's Kyle. We've got two Kyles. Very good. And then the Sting from Highland High out of Medina. Good morning, gentlemen.
Morning. Good morning.
All right, introduce your team to everybody.
This is Patrick. This is Ryan. I'm Mark. This is Corey, and that's Gus Matthew, our team mentor, leader.
Gotta have one of those, huh?
Yeah.
Can't avoid the rules. Crazy.
Exactly.
All right, so these two teams are going to explain to us their robots. They're going to give us a little idea, not too many secrets, but give us some ideas on what they did to build their robots. And we'll talk about this great competition, a huge success story sitting right here, and we're going to tell you about that as well. A great robotics competition right here at the Sting Center. Domo Omegado, Mr. Roboto. You remember that song? Yeah, okay. It's all about the robots. All right, back to you guys in the studio.
Pretty neat. Thanks, Kenny.
Well, something for the kids. All right, speaking of kids, 1,500 high school students from across the United States and Canada are here for the first robotics competition. And we have the meteors from Midpark. Blood, sweat, and tears went into this robot, they just told me. Blood, sweat, and tears. All right. So, guys, tell me about it. Here's a little schematic. Excuse me, BZ. Little schematic of what's happening. Why don't you break it down for me like a third-grade fraction? Here we go.
Right.
Boom.
Pretty simple here. We got a pulley system under the robot that if a ball comes up, it can pull it into the conveyor belt, which it'll ride all the way up and directly into the shooter, which will fire it out right at the hoop, and we can hit any of the hoops with the shooter.
Okay, so what we have to do, they have a secret obstacle course back there, and your robot has to be able to take a basketball and put it in a hoop, right?
Yes.
Now, why'd you go with the underneath?
It's just easier because then we don't have to worry about finding the ball and actually maneuvering to it. We can just go right over it.
Go right over it. I like it. I like it. Okay. So. Midpark Meteors are thinking. Let's come over here. Talk to my Highland Robotics team, and they are the Highland. What's the mascot?
The Hornets.
Okay, but we're calling you guys a Sting. Okay, break it down for me. Here we go.
Right, so as you can see here, this is a 3D model of our drivetrain.
Got you.
On the front, we have a ramp to cross the barrier. Basically, what we wanted to do was we need to be above the midpoint of the barrier.
Okay.
And how it comes up is on here is the ramp. We come up and we slide over the metal of the barrier. Okay. And then it comes up with, here's up close.
Got you.
And we have a high-strength gearboxes and motors. That way, when we're up on the ramp, we can successfully push right over it. Yep.
Okay. You got a little overdrive back.
Oh, yeah.
Nice. Okay, what do we have over here?
All right, this is our schematic of our pneumatic system for the robot. Basically, we got a compressor sending air into the robot. We regulate it down to 60 psi. Then we go to our shooting mechanism, which is the main pneumatic system.
Okay.
We fire a piston at high speeds, which shoots the ball towards the hoops during the game.
Okay.
And then we have a vacuum generator that uses airflow to create a vacuum in the exhaust port of the piston, which draws it back to its original firing position.
All right. So now, how many balls can you guys gather and shoot at one time?
The rules state that we can have 3 balls within our frame at one time.
Okay. Can this handle it?
Yep.
Okay. Very good. Now, who came up with the concept?
It was a lot of, we met at a library 4 hours after kickoff, and we all deliberated kind of what we wanted to accomplish this year.
Yeah.
And basically, all the ideas kind of came together to form this robot. It wasn't one person's idea.
All right. I'm looking forward to checking it out. Good job, guys from Highland. All right, now let me ask you guys something. About how many hours? You guys have 6 weeks to put all this stuff together, right? About 6 weeks to put it together, test it. Who came up with the concept?
I think it was Jake. Who? I think it was our friend Jake on the team.
Yeah. But it was really everyone.
Yeah, everybody
combined.
It was a lot. We unanimously agreed on a pitching machine type shooter.
you unanimously agreed.
Yes.
You guys will never be in Congress because they can't agree on anything. All right, we're good for you guys. All right, so when we come back, they're going to show us some of the materials that they use to make their robots right here at the FIRST Robotics competition at the Wolstein Center.
Those are
by
some
NASA.
smart
They're a big
students.
sponsor. All right,
For sure.
very smart.
Wow,
No
you
doubt.
paid attention in class. All right, 7:26 is your time. Great to see those young kids so excited about learning too.
10 seconds. Good morning, everyone. We are here at the CSU Convocation Center, and we're hanging out with some of the brightest kids in the entire United States of America. That's right. They are participating in the FIRST Robotics competition, sponsored by NASA. And these are the kids from Highland High School out of Medina, the Hornets, but they're the Sting, because they're going to sting them. Okay, so we talked about schematics. Let's talk about the materials you guys used for this robot.
So for our frame, we went with an aluminum C channel. It's lightweight, durable, very good. And then for our drivetrain, we have 2 high traction wheels that give us a lot of pushing power, as well as the Omni wheels on either end. They allow us to take hairpin tight turns around corners.
So these maneuverability
yes,
over here.
they can slide back and forth on the ground.
Oh, yeah, okay. Got you. And then this,
and this is a high traction, so we can get a lot of grip onto the floor for when crossing the barrier or balancing on the bridge.
Excellent. Like the way you're thinking. Okay, what do you have over here? Come over here. Okay.
Thanks to Mr. Reichel of Fluid Trolls, we were able to use this extruded aluminum for our superstructure here.
I got you.
And for the piston superstructure here. And I'd like to thank our other sponsors, Viasat, EBO, and Lockheed Martin. And
you're very smart to get those sponsors. That's how the country works.
Yeah, the rest of our sponsors can be found on HighlandRobotics.com.
Very good.
And now I'd like to give it to my friend Mark here.
Well, Mark, I'm going to run over here because we're coming close on time. All right, my meteors. All right, so what do we have here?
This is wood, and with
Man, I'm so smart.
Yes, with the gracious support of our sponsors, such as the Berea City Schools District and the NASA Glenn Research Center, we can afford all of the parts on this robot. This wood, it's oak. It's very strong. It's very durable.
It's strong as wood.
It's lightweight. It's inexpensive, and it takes a lot to break it. And that would be our entire bottom frame right here is made out of wood.
I got you.
Yeah.
Okay. Over here you have a wheel. What's up with the wheel?
This is a pneumatic wheel. It goes underneath the robot down here. It's basically like a mini bike tire.
Okay.
And it has great grip, so we can get over the bump and the ramps really easy.
Okay, very good. It really is, because you have this. You can air it up. Okay.
It's got air inside.
What advantage do you like with this tire, real quick?
It's got a lot of grip, so we can't be pushed around, and we can get over the bump really easy because it's got cush because of the air inside of it.
Okay, very good. So looking at my awesome people from Midpark, my awesome kids from Highland, when we come back, I think it'll be time to actually unveil the robots. More Fox News in the morning coming up, so stay with us.
Okay. Oh.
Okay, I have my safety gear on. We just had the inspector come over and say, you need safety glasses. All right, so we have them. Dun, dun, dun. All right, now, we have our amazing team, the Meteors from Midpark, and this is their robot. Now, they're not allowed, the rules and regs say they're not allowed to touch it till like 8:30. Is that right, you guys?
Yep.
Okay, so now point some things out, whatever you guys want to point out to me. Show me some stuff.
Well, this is our shooting mechanism that, thanks to Tri-C Team 1270, we were able to get. They CNC'd the materials for us. It's a lot like a pitching machine. We actually had to modify it because they had it so it would load from the side.
Gotcha.
That's what this is for.
Huh.
So Kyle and Garrett worked on it, and they cut it off the bottom, and now we can actually use that to grab a ball if it gets jammed.
Oh, very good.
Yeah.
All right, a little backup here. Okay, and these are the rules and regulations you guys have to follow?
This is our robotics Bible.
Yeah, this is the entire rule book. It's like really big. We printed all these out from the website. Yeah.
All right. So you make sure everything is on the up and up. All right, let's pop over here to my guys from Highland. All right, Highland, what do you guys want to show me?
We want to show you some of the systems. My friend Mark Bloom is going to go through those.
All right, Mark, here we go. Do your thing.
Some of the sensors that we use on the robot, in our autonomous mode, we use a gyro sensor for after we shoot our 2 balls, we turn around 180 degrees so that once we go into teleop, the operator control, we can quickly get the bridge down, get some more balls on our side.
That's cool.
We also have our remote-controlled pan and tilt camera, so we can see the hoops, we can see the balls, and when we're going to collect the balls, we also have a proximity sensor that will be mounted right here, so that we can tell exactly when to turn on our conveyor belt system. And then we also have a pressure sensor that tells us when, if we have enough pressure to shoot the ball into the high hoop, which we always aim for. And
the high hoop, more points.
Points, exactly. Yeah. And so Ryan's going to talk a little bit more about the actual shooting mechanism.
Okay, Ryan, the shooting mechanism. Talk to it.
Yep. So this is, it's kind of covered by the bag right now, but this is our piston that we use to shoot the balls. Usually there's a plastic plate on there that we have to add when around 8:30 when we open up the bag. We have a compressor mounted to the robot on the underneath, and it goes through a systems of valves and tubing in order to get pressure to this system. And we have this angle optimized for the high hoop.
For the three-pointer.
Yep. So we can
go for the money.
Points.
Good man. All right, my guys from Highland, my guys from Midpark, they're going to compete against 15. Well, there's 57 teams these two guys are going to compete with. When we come back, we'll be able to see their robots because the rules will allow. All right. Back to you guys in the studio.
They will come to life.
Very cool. Yes, they will.
Cool. Thanks, Kenny.
Kicking it with the robots.
Yes, indeed. We're at the FIRST Robotics competition, and this is my team from Midpark. Okay, guys, go ahead and take it in there. Now, go ahead. Now, tell us about what's happening here, Kyle. Go ahead and give us a play-by-play.
Well, what they're doing right now is that they have two balls queued up, ready to shoot. They're going to shoot those balls and try the best that they can do to shoot at one of these 4 baskets. With the pitching machine, they're going to turn the wheel, it's going to hit it, and just like a baseball shooter, it's going to throw it right in the basket. Now, if they miss, they're going to be able to pick them up from the floor. So we can see them trying to do right now, driving around, getting position, shooting from the key. All right, and we might see a shot right here.
All right, so now we do a little adjusting.
We do a little adjusting. We try to go back. We got one stuck in the shooter.
Well, this is what happens.
This is what happens. What I have here. So now we drive around and we try to pick that other ball up.
There we go.
That was really just my error.
Okay, that was operator error, right?
Operator error. Sometimes that happens. So now we're going to try to pick up this next ball.
We got it.
So we can pick it up from the floor. Drive around, and ideally we should go around here and shoot. Hey, Garrett, why don't you go in there and move that basket? Move the ball.
Yeah, since this is just a demonstration, we can do that, right?
Stop moving, Yankee. Stop.
Yeah. Okay. Now, Kyle, you started out like this. And now you've actually started working for NASA.
I did. I was on this team in high school. I went to Ohio State for 5 years, and I came back and I got a job at NASA Glenn Research Center, and I'm working and volunteering with this team.
So we can literally see kids start out like this in high school and it actually becomes an occupation for them.
Absolutely. This team is a great place. FIRST Robotics is a great place to learn science and technology and math and put it into application and something that's fun and in robotics. And you can see these kids all have a great time here.
Okay, you see, yeah, I see it. I see how that, the conveyor system is working for you guys. That is pretty cool. It's going to go a little bit closer. All right, we're here at the FIRST Robotics competition right here at the CSU Convocation Center. And this is it's free. There we go. They got one in there. How do you like that? Perfect for TV. When we come back, well, we're going to wish these kids a lot of good luck. Our kids in Park. All right, well, there's going to be more Fox 8 News in the morning, so stay with us. Good job, you guys.
Thank you.